So hello viewers and welcome back to another video on networking. So in today's video, we are going to cover ARP, we are going to continue actually ARP protocol learning, where in the previous video we have covered these three sections. We had a basic introduction and why we need and how it works and very basic overview of ARP protocol. In this section we'll cover packet formats. So without wasting much time, let's get started. Now let's get started with the packet formats. So we just have one packet format to know if you just want to learn the ARP protocol, and every other formats like ARP Request, ARP Reply, and there are a few others that we'll see and discover in today's session. But for all of that, the packet format is same. We change some of the values in here so that we can so the devices who are receiving that, they can get to know that if it is ARP request or reply. So you can have a snapshot of this because this is the one and only packet format for ARP. So now let's gets to know about the fields. So first is Ethernet address of the destination. So that is the destination MAC address. Usually it is all Fs or because destination address is supposed to be not known. That's why we broadcast that network. So technically this will be ARP request for first time. And this is the length of this field is 6 bytes as the MAC address is 6 bytes, right? Now under Ethernet address of sender, so that means source MAC address, and which is also usually the same size 6 bytes. Frame type. So for ARP request or reply, it is set to this is 0806, so this is hexadecimal values, and this is the length of this field is 2 bytes. Hardware type, so it indicates what is the hardware type, what type of address that we want to have, and it is 1 for MAC address, and the length of this field is 2 bytes. Now protocol type, so it indicates that what type of protocol that we are using. For IP address, if let's say we are mapping IP address to MAC address, it is 0800, so hexadecimal value. And hardware length, so indicates what is the length of hardware address in bytes. For ARP request or reply, this is 6. This is set to 6, and usually the length is 1 byte. Now protocol length, so it indicates length of the protocol address in bytes. For ARP request or reply, since we will be using IP address to map MAC address, and the length of IP address is 4 bytes. That's why usually it is 4, and the length of this field is 1 byte. So over here also hardware address length, that is also MAC address, it is usually 6 byte. That's why the value is kept 6 over here. So you can get the idea about fields like this. Now over here, OP, that means operation type, so that is usually length is 2 bytes, and for ARP request it is 1, ARP reply it is 2, 3 for reverse ARP request, and 4 for reverse ARP reply. And what are this reverse ARP that we will see in upcoming slides. Now Ethernet address of sender, that is MAC address of message sender. And remember, this message sender and the destination, they are both different. We will see how they are different in next slides. Then IP address of sender, so that means IP address of message sender who is sending the message, actual message. Then this is Ethernet address of destination, so this is MAC address for destination, and usually it is set to all 0 because we don't know what is the destination address, MAC address of machine. So for ARP request, it is usually all zeros. Then IP address of destination, so this is the IP address of message receiver or destination. So these are the fields that is usually carried in the ARP request, reply, or any ARP packets. Now let's get to know about some packet flows. So these are the three things that you must know. The first is ARP that we will see, and majority of the things that we will talk about, they will revolve around ARP. Now there are two other types of ARP, which is gratuitous ARP and reverse ARP. So this type of ARP request that is usually sent by protocols like VRRP or VARP, we have kept or we have made the videos over there. I will have a link of those videos in the description box, or as well as over here in the I button. You can watch those videos. And basically these these packets are sent to announce the MAC address of particular IP address. So where device they inform other devices that this is my new MAC address. So that's how this Gratuitous ARP is used. And reverse ARP, so this is replaced by DHCP. So this was the protocol that we were using to get the IP address when the device is booted initially, like very initially, before DHCP came. We'll make videos on DHCP in upcoming videos, so be subscribed for that. But we will have an overview of reverse ARP packet or packet captures and packet flows also. So now let's see for each of this type of ARP protocols. Let's see how the packets will be looking. So let's start our discussion with first of all ARP frames. Now ARP frames, so normal ARP request and ARP reply. So we'll follow the same scenario. This is the switch Ethernet 1, 2 and 3 interfaces, and these are the devices connected. These are the MAC addresses. For simplicity we have kept just A, B and C, but usually in real world it's 6-byte value, and we all know how they are calculated. These are the IP addresses, example IP addresses 192.168.10.1, 2 and 3. Now let's say this machine wants to talk to C over here, but it doesn't know the MAC address of this machine C, or this machine which is connected to Ethernet 3 interface of the switch. Now the sample ARP request packet looks like this. So these are the key fields from this packet. So we'll keep destination address, address of sender, and these 4 fields: address of sender, IP address, destination address, and IP address of destination. These 4 fields we'll take, and we'll see how packets are formed. So first of all, destination MAC address. Since we don't know where the destination device will be, we will send this ARP request to all the devices in our local network. That's why the destination MAC address is broadcast address, so that each and every devices in the network can accept this packet and process it. Now source MAC address is A, since this is the device who is sending that packet. Now target MAC is all zeros, because we want to know that what is the MAC address for the destination IP that we have kept over here. That's why in reply this field will be changed, and this target MAC will be the reply for the request that we have made. Now sender MAC address, so again this will be the MAC address of the device who is sending the request. So that's why this is A. Now destination IP is 10.3, because we know the IP address of this machine that we want to talk to, but we don't know the MAC address. That's why this field is all 0. Now source IP is 10.1, because this machine wants to get the MAC address of this machine. So this is the usual ARP request packet, key fields with key fields. Now let's look at the ARP reply. So ARP reply will look something like this, where you can see the destination MAC address is A, because our destination is this machine, and we know the destination MAC address since we have received this packet over here. Now you need to keep in mind that when this machine will receive the packet, it will process the packet since the destination MAC address is all Fs, but it will not reply it because the destination IP does not match the particular IP that this machine has. Now this machine will reply because the destination IP here that is matching this machine. Now source MAC is C, since this machine is sending. Target MAC is A, since this is the device from where we want to send the message. Then sender MAC address is C. Destination IP is 10.1, because this is the IP for the machine where we want to send the message, and source IP is 10.3. Now once this machine will receive a message, it will get to know that this package is meant for me because source IP belongs to me. Then we will get to another layer 2, where we will see that destination. Sorry, first of all, we'll start with the layer 1, layer 2. So at layer 2, we will see that destination MAC address is A, which matches my MAC address. This machine will process that frame, and once this frame is processed, it will get to know that destination IP is also belongs to me. That's why this machine will accept the packet, and then it will get to know that this is the ARP reply, and it will, from the sender MAC address, it will get to know that what was the MAC address for particular request that was sent from over here. So this is how ARP request and reply packet looks like. Now the second one is gratuitous ARP. So let's assume a scenario where the initial setup is same, switch with interfaces Ethernet 1, 2 and 3, and these are the machines, 3 machines connected to the switch, and you can see the MAC address and IP address of the corresponding machines over here. Now let's assume a scenario that these both machines got their MAC address and IP addresses. Actually, MAC address they don't have to get because they have NIC, so by default NIC will have the MAC address. Now let's say there's this machine just got into the network. I mean, we just connected this machine with the switch. Now somehow this doesn't this machine doesn't generate gratuitous ARP packet. It is generated through some protocols like VRRP and VRRP, but let's just assume that this machine wants to send the GARP packet. So that means this machine wants to advertise its own MAC address to all other devices connected in the same local network. So how it does is, it make this gratuitous ARP packet or GARP packet, and this is how it looks. So destination MAC address is usually all Fs because we want to broadcast it to every other machines that are connected in local network, and source MAC is B because we know that we want to send the message. That's why I mean by this machine which is having MAC address B, so source MAC will be B. So as you can see, target MAC is all zeros, so because we don't know who is going to receive this packet. Sender MAC is B since we know that this machine is sending the packet, and as you can see, the destination IP and source IP are same. So if you want to identify, if you have the packet capture and if you want to identify that which packets are the GARP packets, so you can just identify by looking at the destination and source, destination IP and source IP, because both will be same. So this is how GARP packets are formed. Now lastly, we'll end this discussion by looking at the RARP packets. So that means reverse ARP packets. So as just a note that this was the very old protocol, and nowadays nobody use this protocol, but this was the legacy protocol which got replaced by DHCP. So before DHCP, this was the method which was used to get the IP address for the machines which are connected in local network. So how it does is, first we'll send the R reverse ARP request, and as you can see, this is how the packet looks. So destination MAC address is all Fs because we don't know who is the machine that will process this frame. Source MAC is B because this machine wants to get the IP address. As you can see, initially this machine doesn't have the IP address, so this packet will be sent during the boot process. Now target MAC is B, and source sender MAC is also B, and source MAC is also B. So all three addresses are B because at the end we want to get the reply on that machine, and destination and source IP both are 0. So this is how the typical RARP request packet looks. And in reply, we will receive this kind of message, this kind of packet which is having destination MAC address B. Source MAC is X because there might be another machine who will process this frame and reply us back with the IP address. So I am assuming that there is machine which is having we will process this message and which is having some source MAC address, let's say X. Target MAC address is B, sender MAC is X, and destination IP is like this 10.2, and source IP is like 10.100. So this is the machine who will have that service RARP. Who will have that service which will process this RARP request packages, and this is how it will get the IP address. So that's how typical RARP packets are looking. And coming about the important RFCs, so I have just listed out few RFCs for ARP protocol and why it's important. you can just go through on the internet and just search for these RFCs, because I'll not go for each and every changes, because the changes are very large. So yeah, that's it for this video. I hope you have got the idea about the packet format for the ARP protocol. We'll in the next video we'll have a discussion on CPT and NS3 demos. So that's it for today's video. We'll meet in the next one. Till then, keep learning and keep exploring.